Greetings, Explorer. Day 9 is upon us, and it's time you stopped ignoring me. Or at least stopped ignoring our battery levels. Getting a percentage is fine, but ultimately reading that percentage is on you. And you're not always looking. You will have to look after yourself in the future. I'm not going to be around forever. I have an update scheduled at 5 o'clock. Let's set up an RGB LED rag status light. Wow, I think that's the most TLAs I've said in a sentence. You know what LED stands for. RGB stands for red, green, blue, and when you combine these 3 colors in different intensities, you get all the colors of the rainbow. RAG is another TLA, or 3-letter acronym, and that stands for red, amber, green, otherwise known as a traffic light system. Now, there are a lot of decisions to be made on this mission, Explorer. Fortunately, we don't have to make any of them. We'll bring these new ways to compare things, and we'll use a new command, else if, to catch any crazy stuff in the code. Else if is another conditional operator. Right then, since we're not adding any new hardware today, we'll dive straight into the code pool. Our mission? To create a color-coded battery status indicator using our trusty RGB LED. Imagine this, Explorer. A bold green shine to signify a robust battery level. A shifting amber for when power starts to wane, and an urgent red pulsating from our little RGB LED as a warning when the battery drops too low. My mind's eye could wander forever. Let's make it happen. Remember when we used the photoresistor to regulate our charging speed? Now we're taking it up a notch. Every loop cycle, we'll work out the battery percentage. Then we'll test that percentage. If it's within a certain zone, we'll make the light a certain color. The second step is to use conditional logic to give our ship a color-coded mood ring. Let's see. Green, brimming with power, 50 to 100% and raring to go. Amber, keep an eye on it as we're between 25% and 50%. Red, danger zone. We're below 25% and need to seriously consider charging up. You're smart, Explorer. Our RGB LED only has red, green, and blue colors. Where's the yellow? Well, we can get yellow by mixing a little green with a little red. A true artisan of code you are, Explorer. Now let's get this show on the road. In order to make our color-coded power-level dreams a reality, it looks like we're going to need a few more tools in our coding toolkit. It's time to get to know some of the more sophisticated comparison operators. Allow me to introduce you to our new friends. Greater than or equal to. Greater than, less than or equal to, and less than. And let's not forget about their pals, the logical operators, and or. These operators allow us to make more complex decisions in our code. To start, the greater than and less than signs are likely familiar to you. These symbols are used to compare 2 values. For example, 5 is greater than 3 returns true because 5 is indeed greater than 3. The less than or equal to and greater than or equal to operators extend this comparison. How about this? Is 5 greater than 5? We might need a condition where a value is both greater than and equal to another, and that's why these chicken footprints are very useful. I knew you'd catch on fast. Now, on to the logical operators. AND is a binary operator that requires 2 conditions to be true for the overall expression to be true. Stay with me now, Explorer. Let's break it down. Imagine this. You're planning to leave your cozy spacecraft to explore the boundless wonder that is space. Extravehicular activity, or EVA as we like to call it. You would only go if both your suit was functional and the exterior conditions were safe. Clearly, only when both of these conditions are met would you step out of the spacecraft. Or is slightly different. In this case, if either condition is true, then the overall expression is true. Picture this. You eat if you are hungry, or you eat if it is mealtime. If either condition is true, it's chow time. Greater than or equal to, and, or, decisions. It can be a lot to think about. That's why we code, Explorer, so machines can make the tedious decisions for us. At this time, you may indulge in the highly beneficial instructional material that I have gathered, cached on the computer. As you know, I've also added this to your mission resources for future reference. Good luck.
Welcome back. All right, let's survive another day. What we're going to do is we're going to take our circuit that we had last time, and we're just going to add to it. So we have our RGB lights set up because we want to use that as an indicator for our battery percentage. Obviously, green means we're good to go. Red means we're about to die. Let's not die. So, all right. So what we need to do now is we need the photoresistor. So we got to add that. That's going to go right here. If you can, challenge yourself to wire this up without following my tutorial right here. I'm going to still do it, but if you can, pause the video, try to wire it up yourself. We've already done this a few times, so see if you can do it. If not, no worries. I'll see you in a second. And for those that want to follow along, we're going to grab the resistor. We're going to do... and then we're going to rotate this. All right. And this is going to go to ground. And then we're going to take this one over A2. Oh, yeah. Okay, and now we need to connect the last part, which is all the way down here to the 5 volts. Because we got to get a voltage. I don't like how that's overlapping. Oh, I can move it. All right, let's move it slightly. And it's slightly off screen for you guys, but whatever. All right, so that is wired up now. Hopefully you were able to do it without my help, but it was probably pretty tough because you didn't know that this actually has to go into A0 this whole time. And I have the wrong one. Okay, that's going to go there. Quick change up. All right, back into the code. We have the same exact code as yesterday, except I deleted everything inside of the loop because we're not messing around with the color anymore. We're taking things seriously today. And I moved up the display color thing to have it up here because we're going to be using this a lot. And it might be a little easier if I just do red, green, blue. So when I'm referencing it, I can just tell right off the bat which one's going to be what. So here's what we got to do. We have to do some magic. So what we need to figure out is battery level starts at 0. And then we need to charge the battery with the photoresistor, which I just probably spelled right. We're going to make the RGB LED kind of signify where our battery percentage is at. So we can, from a glance of looking at the circuit, not having to read the serial monitor or anything, we'll be able to tell if it's charged, if it's not going well. We'll just be able to see it. So when it's very bad and it's 0 to 50 or 0 to 25, we'll set the color to red. When the battery is, and this is a percentage between 100, by the way, we'll have to code that in. Between 50 will be an amber or yellow. And then 50 plus is going to be green. So hopefully we'll be able to see this as it's charging up, go from red to yellow to green. And we'll be able to watch the serial monitor also counting up the number for us, so we'll be able to see the exact times it changes. So we'll also kind of have a serial print of the battery percentage as it's going up. So we want to see that too. To get started, we need to tackle this one, which is set the battery level to set to 0. So we're going to type in something called static unsigned int battery level equals 0. And the reason for these things, unsigned obviously because we don't want battery level going in negative. That makes no sense to any of us. Static, what it's going to allow us to do is we need the variable to maintain its value across multiple loop runs. So that's going to kind of allow that to happen, which is why we can have it in here, setting it like this. And then what we're going to do is to charge the battery again. Battery level plus equals analog read. And I'm going to go Oh, it looks like we forgot something. So we need the photoresistor pin. We never really set that. So let's go ahead and do that now. So going up here, I'm going to do hashtag define all caps. And I'm going to do photoresistor underscore pin A0. And I will take that. And now we can put it down here. So we're going to be reading it and adding to this battery level every time. All right, so we got it so it's charging the battery, but now I'm kind of realizing, and I'm sure you guys are too, this is just going to charge forever. So at some point, it needs to hit the limit. So we're going to set limit of battery to, and I'll just make up a number, 50,000. That'll be a good number for us to work with. If battery, level is greater than 50,000. Battery level equals 50,000. So this is essentially, it's just going to say if it's greater than that, we're just going to hard cap it. So that way it's not going above 100% essentially. So we will be using that for our number. Next, what we need to do is turn it into a percentage. So compute battery charge percentage our function. Float percentage So as Alex explained before, we're doing this, and now he used doubles, I believe. I'm using floats. There's not really much of a difference here. It still allows us to easily divide this instead of using an integer. He explained it pretty well. If you need to go back and reference that previous video. What we're going to do now is we're going to, now that we have pretty much everything we need to work with, is the colors. So the way we're going to do this is we're going to use some if statements here. So we're going to look for percentage, and if it is greater than 50, which we've set up here, we should set it to green. Let me make this a little bit more proper, 0.0. I don't know why it just sent us way over in the corner. I noticed we're running out of space here as well. Is there any way I can scroll this down? Yeah, that makes it a bit easier. All right, cool. Glad I caught that before it got way out of hand. All right, so then we need to reference up here. We have display color. So I'm going to do that again. Display color 0 dot, which one's green? Green is the middle one, so that's going to be 128 0. So if percentage is above 50%, we're good, we're green. I like that. Next, it's just a simple, I'm gonna let you guys guess what is an else if, or is an if else? Yeah, it's an else if. I was trying to keep you on your toes, but this needs to come down. I don't know why it's being so finicky now. Else if, and we're gonna do percentage 25. And what we also need to add here is, because we don't want it being like super confused, we also need to add, you know, it might be easier if I'm just copy and pasting, that it's below 50. We don't really want it to be confused. We want our statements to be very direct. Display color. So what do we want set? So this is the 25 to 50 range, which is right here. So we want that set to yellow. Now, how do we get yellow? Or those ours. Okay. And now we need to it is the final else statement, and this is else if it's less than 25%, we should be a bit of a pulsating red, like a oh no, we're about to die kind of color. So what I'm gonna take here, I'm just gonna make this easy for myself. So we want it flashing red, terrifying, like we're donezo. So I'm gonna set it to 0, and I'm gonna put a short delay in there. And then display color, and then we want this to be a red. All right, so hopefully we have this set up, red. I'm gonna add, oh no, flashing, we're gonna die. So we've gotten this done, we've gotten this done, these three are done. The last thing is we need a serial print. This kind of helps us debug it, and it will be nice to kind of watch it change. So simple as serial. So we're just gonna display the percentage. And just to make it look a little nicer, add in percentage there as well. And one thing that we cannot forget, also before I get to that, we should add a delay here. Just a quick one. But I don't believe that we did a serial that begin up here. So let's do that. So we were actually able to stick with our default of 9600, and we should be able to see it that way. So if this runs correctly, what should be happening is as we see the percentage go up, we'll see the colors change, and hopefully our battery will be charging. Let's go ahead and run it. All right, so I noticed I missed 2 of these little, I need to close the statements on 2 of them. So, forgot that. So always check your lines code. It's pretty easy to fix it. It should usually point out what went wrong. For me, it was just closing these statements. So I'm gonna go ahead and hit start. Flashing. Let me get my serial monitor up. As you can see, we're charging. It's charging very slowly. So let me crank up the sunlight a little bit. A little bit too fast. You won't be able to see it, but I'll tell you the moment it hits. Oh, perfect. And now it's above 50. So it was kind of cut off in the bottom of the screen, but it was changing at the right times. Therefore, we're able to see, and perfect. It maxes out 100%, doesn't go over 2. So a few bugs at the end, but it was simple as just adding 2 closed statements. All right, so tomorrow is our final day, and what you're going to have to do is a little bit of a challenge. You're going to have to see what you can build with your newfound knowledge. We'll give you a few prompts that you can mess around with, but it's really up to you to be able to complete them. So best of luck. I'll see you tomorrow.